Welcome back, everybody. So let's continue. By the way, I made a mistake, just a stupid mistake. We are still on summertime. So right now the time zone is CEST, and then at the end of the month it will be CET. But as I said, the two time zones both exist. It's just that we use only one of these at the same time. But the ways there are places where actually the two of them coexist. For example, is anybody from Australia? Maybe on Zoom. So in Australia, you have a lot of time zones. You even have one with, in the center, it's half an hour away from the east. And then what happens when you switch to summertime, it's only, I think, the south part that switches, but not the northern part. And so then you have, at the same time, the winter time and the summer time in different regions. All right. And by the way, if I make mistakes, you can also make mistakes. It's totally fine because we are learning. So we learn actually by making mistakes, and that's how the brain makes progress. It's called productive failure. If you're interested in the topic, there's a professor at ETH, Manu Kapoor, who wrote a lot about this. And what that means is that you can ask all the questions you have. It's the case in the lecture hall. On Zoom, you can also ask questions. Some of you write private messages to Martin, so this is of course great. Do not hesitate to also ask questions, and I can also answer them in real time. So let's continue with duration. Duration, it seems simple, it's just a time interval, right? So again, that might look like it's just a real number. But again, it's all in the representation that we have of durations that again, we use days, hours, minutes, and so on. And it can get quickly very complex. So we have years, months, days, hours, minutes, seconds. And I put this black line between month and day. Do you know why? What is difference between month and day? What is different from year, month, or day, hour, or hour, minutes, second? Anybody? Yes? Exactly. A day is not always the same number of days. So this is why I put the line here saying, be careful. You should not cross that line if you want precision. You can say 2 years and 4 months, there's no ambiguity. 3 hours and 14 minutes, there is no ambiguity. But if you say 2 months and 30 days, well, is that 3 months? Is that 3 months minus 1 day? Is that 3 months plus 1 day? You know, it's that's why you need to be careful. So typically we avoid crossing that line, but everything else is possible. As I said, it's the sexagesimal system. There are several reasons for that. One has to do with the fact that the moon orbits the Earth almost 12 times as fast as the Earth orbits the sun. So that gave us this number 12. But also 12 has the nice property of being divisible by 2, 3, and 4, and 60 also by 5. So that's also one of the reasons why we took this system. All right, this is the menu, à la carte. So you can pick the intervals you want, year to month, day to second. That's basically, for example, day to second, meaning, for example, 1 day, 2 hours, 3 minutes, and 54 seconds. That's an example of interval day to seconds. As always, the number that you have in parentheses, that's the precision after the seconds. Do you want to go tenth of a second, hundredth of a second, millisecond, microseconds? So that's what it's for. Is it all good for everybody? Yes? Okay. So these are durations. Then we have binary data. What if you want to upload pictures or videos or you know, whatever you want? Well, you can absolutely do that, and we have binary types for that. Music, like whatever you want. In fact, it's enjoying more and more popularity right now because we can use AI on these things. And with vector databases, of course, it's not in the scope of this lecture, but now with large language models, it's really improved a lot just in the past 3 years. It's amazing what we can do now. A lot of value for the companies who can put all the data they couldn't query before. They can just all put it in a database and index it and access it faster than before. But anyway, These are the types, as always, the menu. Binary, var binary. It's actually, if you think of it, that's just like strings, right? Instead of char for strings, now we have binary. It's just that it bytes instead of chars. Var binary is like varchar. You just cap the number of bytes, but it's varying. And then they even have in common that the standard is normally a blob, character large object, blob binary large object. So blob should be the standard in SQL, but PostgreSQL doesn't follow that standard and uses byte A instead as the name for the type. That would be unlimited. Basically, you can upload any file of any length. Of course, there's always a physical limit somewhere, but it's very high. By the way, it gives the impression, when I say PostgreSQL doesn't respect the standard, that looks bad, but actually PostgreSQL is one of the systems that respects the standards the most. So if you took other systems, they are further away from the standard. So this is the reason we use PostgreSQL. It's actually pretty close to the standards. I'm not aware of any implementation that strictly follows the standard, right? It's just real life. Okay. And I have a summary for you if you wanted an overview of what we've seen. So these are the must-know. You really have to know these types. As we discussed before, they are synonyms, so there are others, but this is the basic ones that you really should know. I think all of them are standard. I checked, except again club and blob that are normally the standard ones, but it's text and byte A in PostgreSQL. Any questions? On Zoom? Any questions? No question? Okay, then we continue. But again, don't hesitate to interrupt me. You can even ask questions on previous parts. That's not a problem at all. That's what I'm here for. So then we are going to move on. So now we have the restaurant menu and we need to do the cooking. So I'm going to show you now how concretely in PostgreSQL you can use all these types that I gave you and create tables, create schemas, attributes, fill it with data. So we are going to go comment by comment, one after the other, and I'm going to show you how it's done. And you can actually do it yourself. If you have the Docker and the Jupyter Notebook, you can type all of that and do it on your screen in real-time interactive. So here's what we can do in PostgreSQL. You can create a table from nothing, right? You can instantiate a table. Of course, it's going to be empty at first. You can modify a table in various ways. You can add columns, you can add rows, and so on. Or you can drop a table. It means that you can just completely remove it from the system, delete it, right? Just for vocabulary, there is the word drop and the word truncate. They mean different things. Drop means the table is gone, doesn't exist anymore. Truncate means the table is still here, you just removed all the records. You emptied it, right? So it's there's a slight difference between truncate and drop. So we'll create, modify, and drop the tables. So I'll start with creating tables. Again, when you create a table, it's empty at first. So you just say, these are my attributes, these are my domains, and I'll show you a few constraints that you can put, but at first it's empty. That means that the set of maps, remember it's a set of maps, the set is empty. There are no maps in there at first. So we specify a name for the table, we give it a name for every column, the attributes, and the domains, the types of the attributes. Domain is the name that is used in the theory, and type is the name that is used in practice, but it's the same domain and type. So that's an example. Let's jump into the water. Create table, hello world table, name, text. So when I do that, quickly, I'm pretty sure the answer is going to be fast. How many attributes will we have in our table? Okay, everybody at the same time. 1, 2, 3. 0. Okay, let's do a poll. Who is for 0? Who is for 1? Who is for 2? Okay, now you can answer this one. How many records? 0, exactly, 0 records. So we have indeed 0 records and 1 attribute in there. So now, just in terms of visual, it's purely a visual that I have here. I will write the name of the table right here at the top on the black background. And then in purple, I will write the name of the attributes. And then the type, I will add a special mention here, typically yellow. I mean, here it's red, but in another color. What's important is that it's the type. It's not a value. It's really the type, right? So in here, it's empty. There is absolutely nothing in here. So absolutely, you said 0, and there is indeed 0 records in there. And we have just one attribute, that is the attribute name with type text. And you remember that the type text corresponds to strings with arbitrary length. Okay, who is with me? Right? For whom is that intuitive? Right? It's the goal of the language. It sounds like English, right? Create table, hello world table with an attribute name of type text. Okay. So of course, if you want more than one attribute, you can also do that. It's pretty simple. You just list them. You just need these little commas in there, right? Comma, 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 right? And then you have all of these, So how many attributes will we have in the table? Let's try again. 1, 2, 3. Okay, let's poll. Who thinks 1, 2, 3, 4, 5? Yes, exactly 5. How many records? 0, exactly, always empty. So indeed, now we have a table. You see persons, that's the name of the table. That's the name that I specify right after create table. Then we have first name, and the type here I put in yellow, middle initial char1, last name text, birth date, date, and scientist Boolean, right? Okay, so you see, it's easy. Name of the table, names of the attributes, and here that's taken from the menu that I gave you in the first hour, right? You just pick whatever types you want, and you put them in here. So now I want to say a few words about the case, because that's often a source of confusion. So I'm going to take just 1 minute to give you a few details. You know, the case means uppercase, lowercase, right? I might have told you in the first hour that lowercase and uppercase has to do with the boxes in which we put the Buchstaben several centuries ago. And the upper part of the case was the uppercase letters, and the lower part was the lowercase letters. So you need to know something about PostgreSQL. Is that, imagine, let me show my geeky part. I just put some random uppercase letters in there. And if you look carefully at the table, it's actually all lowercase, right? So that's the thing to know. If it will put everything in lowercase when you do that. Now, that is not standard because SQL normally says it should put everything in uppercase, right? So that's, again, a difference from the standard. But anyway, even if I try to put uppercase letters in there, it's not going to have anything uppercase. But I can force it. If I really, really want to force uppercase, I just need to add the double quotes right here. And here you see now it took my uppercase letters, right? So that's the thing to know, which is an opportunity for me to repeat that double quotes are for attributes. That's for forcing the case for attributes. Single quotes are for values, the string values that you put in your queries. Double quotes for attributes, single quotes for values. PostgreSQL is very strict about it. It will throw an error if you try to put single quotes on the attributes, and it will throw an error if you try to put double quotes on strings, as we will see later. Who is with me? Right? Okay. So now you know that can be a source of confusion. Yes, there is a question over there. Yes. If you put everything in uppercase, it's still going to lowercase it all. Oh, so you mean the keywords in blue, right? Yes, yes. So here, it's very good that you ask because that's also something important to know. This part right here, you can have it lowercase, uppercase, it doesn't matter, right? It will accept it, it will work fine. So it's a matter of preference, I would say. There are people who write it lowercase, there are people who write it uppercase. Historically, it was written uppercase, and this is what people are used to, right? So they are used to seeing the commands in uppercase. You can try lowercase, it will work too, and that doesn't make any difference. So the create stable part. And by the way, if I go further to answer your question, the same goes here. The names of the types, you can also put them in uppercase. That will work just fine as well. And again, it's a matter of convention. There are people who prefer to have them in uppercase and other people who prefer to have them in lowercase, and both is fine. On my slides, I tend to have them in lowercase, and I have the keywords in uppercase. Did that answer your question? Yeah, thank you for asking. Very good question. Yes? That's probably also a matter of convention. I think, for example, true false is typically written in uppercase. I think I don't know everything by heart because these things can vary a lot between implementation. We can try it together. I mean, I might show you the Jupyter notebook. A lot of that has to do with conventions. People often even fight over it. You probably see some social media posts about where to put the curly brace in Java. Should you put it at the end of the if or on the next line and so on? People fight over that. It's really not important at all. The only thing that's important is that within a team, you agree on something, because then it keeps the code clean. But really, other than that, it really doesn't matter. It's just a matter of preference. Right? Did I answer your question? Yeah. All right. Any other questions? On Zoom? Okay. Should I continue then? Yes, a question there? So the indentation is optional. You probably have Python in mind, right? In Python, you really have to have the spaces and the tabs. But here, that's not the case. You could even have this on a single line without any line carried return and so on. That would also work. But the parenthesis is important. If you don't put the parenthesis, then it's going to complain, right? Something that you need to be aware of is that it might be that some other systems than PostgreSQL might have a slightly different syntax, right? They might put the parentheses in a different way and so on. But here, there is no secret, right? You just need to look up the documentation, but that's the easy part, right? It's just a matter of getting used to it. So if later you join a company and they use IBM or Oracle or any other system, you just look it up in the documentation and then you know, and then you just follow the documentation. Right? Does it answer your question? Yeah, awesome. SQL is a little bit like Schweizerdeutsch, right? We have Zürichdeutsch, Baseldeutsch, Berndeutsch, Ostschweizerdeutsch, Walliserdeutsch, Embry, Embruf, but we understand each other, right? And so this is the same thing here. We have SQL that is the standard, and you can view all of the vendors that just have their own dialect of SQL, but it works. Okay. All right. So let's continue then. So now you know it's all put in lowercase. The keywords, it doesn't matter uppercase, lowercase. The types, it doesn't matter uppercase, lowercase. And the literals, we can look together whether it matters or not. Okay. Now that's again my mathematical part. You know, the mathematicians, they need to look at the corner cases, right? So if you have vector spaces, there has to also be vector spaces of dimension 0, right? And so if you want to create an empty table with 0 attributes, it is absolutely possible. You just don't put anything and you can, right? I don't know what it's for. It could be for just creating the table and then you can decide later, because you will see that we can add the attributes later. But theoretically, that exists, right? You can absolutely have maps with 0 attributes. That's mathematically perfectly fine. Okay? But practically totally irrelevant. So I'm just jumping on the next slide. Now, once we have created a table, we can drop it. So we just need to specify the name. And again, you will see the syntax is very easy, right? Drop table followed by the name, and the table just goes away. And that's it, right? Then it doesn't exist anymore. Okay? That should also be intuitive. By the way, I didn't mention it, but there is a semicolon at the end of the comments, right? That's to separate them. I think the last one, it doesn't complain if you don't put the semicolon, but when you have multiple comments, one after the other, then the semicolon has to be here to separate them. It's the same in Python, I think. Even in Python, it's optional. You don't need the semicolon, but you use it if it's on the same line. In SQL, you do need the semicolon even if it's on separate lines. So if you get an error, then it might be you're missing the semicolon. Anyway, drop table. Now, if the table doesn't exist, so if you try to execute it a second time after that, if it doesn't exist, then you get an error, right? If it doesn't exist. And now that can be very annoying. Why? Because typically when you build a prototype, like let's say you're a startup and you're building a prototype and so on, then you might have once in a while to reset everything and start from scratch. And typically what you have is a SQL script that just create the whole database. And by the push of a button, it should just recreate everything. In these scripts, what you typically start with is to drop the tables, and then you create them again. But the problem is that if you just write drop table in your script, then it will behave differently if they already exist or not, right? And that's very annoying because then you need to either execute them or not. So there is a trick that people use. They just add drop table if exists. And that's going to just work whether it exists or not already, it just works. And then you're guaranteed at the end of that there is no table. So this is very popular with database administrators or in the scripts that initialize the system. By the way, in the Docker, in the exam Docker that you have, we have scripts like that initialize the whole system, and we have SQL commands that create tables, create schemas, and populate it with data so that you can use them for the exam and for the exercises. All right, so just drop table if exists. That's not going to have an error if the table doesn't exist. And in both cases, after that command, you're guaranteed that the table doesn't exist. Who is with me? Right, okay. So now that we have created our tables, but with 0 records, we are going to populate them by inserting tuples. Remember that tuple is the same thing as record, is the same thing as row, is the same thing as map. That's just the single lines on our tables. So what can we do with these records or these tuples? Well, we can insert them, we can update them, change the values, or we can delete them. That's the 3 things we can do, and I'm going to show you one by one how this is done. So let's first insert tuples, because this is how it starts. This is also things that you have in initialization scripts when you populate the tables. So let's say I have created a table, and I said probably create table, hello world table, open parenthesis, name text, close parenthesis, semicolon. And I got that table that you see at the top of my screen. And now it's empty, of course. And now I say insert into hello world table values Einstein. So the table after that will have how many attributes? Who thinks 0? 1? 2? So 1 is the majority. How many records? Who thinks 0? 1? 2? Yeah. So 1 actually wins because we insert, you see, insert into hello world table values Einstein. That adds a record with, you see the value Einstein right there. So now our tables has a record. It's a map that maps name to Einstein, right? If you remember the model. Okay. So now I have a table with 1 record. Now, if I again do insert into hello world table name values Gödel, I'm inserting a new value. The difference with the previous one is that I specified the column. It's optional, of course. I didn't do it the first time. You see, the first time I just set the table. Now I specified the column name. I don't have to, but I can. So now I say its name. So name associated with Gödel. That's my map. And then I have how many attributes now? Who says 0? 1? 2? Majority of 1. How many records? Who says 0? 1? 2? Majority of 2, indeed. Now we have Einstein and we have Gödel, right? So I just keep inserting and inserting and inserting all the tuples I want. and it's going to just grow the table. Okay. So what did we learn here? We can specify in parentheses after the name of the table the specific attributes for which we want to insert data, and that's optional. Okay. Now, that was a table with only one attribute, right? But what if it has more than one attribute? Well, this is an example where I created a table with 5 attributes. That was, in fact, the create table that I showed earlier. Let me see if I find it. That's the one. Yeah, that's the one. I created the table this way. It's empty. I go back to where I was. And so after creating that table, I'm inserting values. And now, so this command is going more complex because now I am inserting 2 records in the single insert command. So it doesn't have to be a single record. I can also insert 10 or 100 records with a single command. What do? I just use a comma to separate them. So I say parenthesis, then all my values comma separated, close parenthesis, that's my first record, then comma, and then my second record, like this. The indentation is all optional. It's only a matter of cosmetic. We human beings like when it looks nice, and there are even people who align the values with additional spaces. I do it on some of my slides. You will see. It's all a matter of convention and cosmetics, right? It just looks nice. So now with a single comment, I managed to insert 2 records. So now I have 2 records and 5 attributes in my table. Who is with me? Right? So now you should be able to write such things in Jupyter notebooks and all make it work. Okay. So if everybody is following, then I'm going to go further and show you more things, right? So here are more things. In the case of strings, I told you single quote and you can add it. The numbers, you can also directly add them without any quotes. Booleans, by the way, you saw false true. These are the literals that we mentioned earlier. In that case, I put them in uppercase. But in some cases, you want to force a type or specify it explicitly. You see what happened with the dates? The dates, I said it's science fiction, right? So it's in the future. That's why 23rd and 24th century. But anyway, Kirk, March 22nd, 2233, that is a date. So what happens is that PostgreSQL takes that, it's a string, and then it sees the associated column, birth date, is a date. So it's going to turn it into a date, right? It interprets the string as a date. If the string that you put in there doesn't have a format like this, and it is not able to interpret it as a date, then you will get an error. If you just put foobar at that place instead of 2233, you'll just get an error, right? It has to be a date literal. But you can make it explicit like this by adding the name of the type. You see right here, before the date, I say date. What you have here is the same as the type that I showed you in the restaurant menus. That is the same that you have in the create table statements. And again, it's a matter of convention, but at these places, people tend to put it in uppercase, the date prior to the string, maybe because it catches the eye, right? You immediately see that here you're specifying that this is a date. So just the name of the type, a space, and then quoted in a single quote, you have the what's called the literal corresponding to the type. Okay. Just to have fun, I added Boolean explicitly here. I don't have to, but I did it here. I didn't do it here. It's optional, right? And now you see that you don't have to just put true or false. It accepts other things. It accepts on, off. It accepts T, F, even 1, 0. So there's various ways. So that's going to create a false here at the end, but I can just put off. And I can also put just T. Or TR, I think is also accepted, or any prefix of true and false. And then this is going to create the Boolean true right here. Who is with me? Okay, awesome. So what we learned on that slide is that we can put the name of a type followed by a string literal in single quotes to force that type. It's optional because most of the time, even if you don't do that, PostgreSQL figures it out from the schema. So it will guess your intention. Okay. which is an opportunity for me to dive into these things because I use the word literal. I said this thing right here is a literal corresponding to the date type. And so if I give you a bit of theory of the way that things work, is that when you have these domains and these types in the tables, typically you have a mathematical object or an abstraction in mind. For example, when you say that the type of a column is an integer, and then you have integers in there, as a human being or as a user, you think of mathematical integers, right? So if I tell you 4, you think of the concept of the number 4, right? For example, one way to define them, I mean, there's many other ways, and mathematicians also lost their mind over it, but you can define 4 as the equivalence class with all the sets that have 4 elements in them, right? Which actually doesn't work because you can't have sets of all sets. You need category theory and so on. But just to give you an example, it's the concept of 4 that is meant to designate the cardinality of sets that have 4 elements. You can count 1, 2, 3, 4. That is the value space that I put on the left. I took 4, so let me take 4, right? So it's the concept of having 4 elements. But you know that now, for just a few thousand years, it took a few million years for us humans to figure it out, but after a few millions of years, we realized that this concept of counting things, we can encode it with symbols. And so it's very important to realize that this here, 4, 0, 4, or 40e minus 1, that's divided by 10, so that's also 4, that's also 4. These are representations. You can write them on a piece of paper, you can write them on a SQL query, but it's only a lexical representation in the lexical space, how you can encode it as a string, as a lexical value. But all of these is a lexical representation of the mathematical object that is the number 4. Who understands the difference? Who doesn't? Who understands the difference? Who doesn't know if they understand the difference? Okay, see, so let me re-explain. Let me explain it in this way. Imagine that we managed to find extraterrestrial life in the universe. We discover signals from a planet far away. It's very likely if they emit signals that somehow they are advanced as a civilization, that they have mathematics, they have physics, so it's the same universe. So it's very likely that they would also have the concept of 4, right? Just like they have the concept of 3, they might have the concept of the atoms, the hydrogen atom that has one proton, helium that has 2, and so on, right? So they would have this concept. But do you agree that it's very unlikely that what you see on the right would be the symbols they use, right? The symbols on the right, these are ours here on Earth, and even in specific places like in English. If you look in other systems, like in the Devanagari script or you know, any other systems, it's for example, in Chinese, in Japanese, it might be written differently here, right? So you need to distinguish between the representation of something as you write it on paper and the actual thing, right? The actual number 4. This is what I'm saying here, right? So here the same goes for 1. You might have multiple representations here and multiple representations. The same for the Booleans. You have the concept of true, but it can be T, true, Y, yes, on 1. These are representations of true, right? For false, F, false, and no of 0, right? For the dates, I put a few representations on the left. This is how you would represent as a string a date, a time, a timestamp, and so on. Right? That's a standard. It's called the ISO 8601 standard for the dates and times. But do you agree that what you see on the right on that slide, that's only a convention, it's only a representation, right, of the dates? Who now feels they understand the difference? Right, awesome. So there's the values themselves, and there is how we write them down in a SQL query, which is different. Right. Okay, so now if I go back to the query, you see that what I have in my query is a string representation of my date with the ISO 8601 representation that I then convert to a date. And here, what I actually have from a logical perspective is an actual date. This is actually March 22, 2233, right? Who is with me? Right, very good. Awesome. It's a bit, for non-computer scientists can take a while to get used to, but this is the concept, right? The way to think about it goes like this. Okay. I still have 10 minutes to scare you a bit more. Here's how. I told you a bit earlier on my slides that when you insert into a table, you can specify optionally the column, right? You remember? Let me show you when I did this. Here I didn't. I just say insert into the name of the table. And here I did, parentheses name, right? So I'm going to do it like this. But you might notice here that the columns that I put in these parentheses, first name, birth date, and scientist, do you agree it's not all of them? I have 5 columns. In my original table, I have 5 attributes. But here I'm inserting only 3, first name, birth date, and scientist. You see that middle initial and last name are missing here, right? It's because Spock doesn't have a middle initial and a last name in Star Trek. It's just Spock, right? So what do you think is going to happen when I do this? Or in other words, what would be the problem, or maybe a rule that would be broken? If you think about it, I see one raised hands here. So yes, go ahead. Yes, that's exactly what he does. Indeed, it leaves them empty. So it would leave middle initial and last name empty in the new records. What does that break? So let me give you a choice menu, or maybe you can answer directly. Exactly, relational integrity. It breaks relational integrity. Who agrees that it breaks relational integrity? Many of you. Look here. And if you still don't see it, here. It breaks relational integrity. So my cat is screaming because that's not good at all. Because I told you tables have relational integrity, domain integrity, atomic integrity. Well, again, that has to do with real life. Is that in the beautiful world of math, when we define tables, and that's the case with the relation definition, we really want a value of the domain in every tuple. But here's the thing. In the real world, you might not always have the data, or you might not want to show the data, or maybe it doesn't apply, like in the case of Spock. Spock doesn't have a last name or middle name. So there can be many, many reasons. So even though in the beautiful world of math, we would strictly have relational integrity and all the others, what the real life implementations like PostgreSQL do is that they allow you to break these rules a little bit, right? And in this lecture, we are going to break the rules a little bit, relational integrity mostly. In big data for engineers, we'll break the 3 of them, right? These are the more recent systems. So you just need to be aware, PostgreSQL is able to break relational integrity, but I'm saying a little bit because how does it break it? Just by omitting attributes. It's not the same support because some are missing. What it does not allow you to do is to have extra attributes that are not in the table. That you cannot do, right? So it can only break them by omitting some attributes. Who is with me? Right? Who feels like the cat? I do, right? Okay, so we have this, and how do we do this? It's called null. So null is a physical implementation of the fact that we break relational integrity. So we just put nulls in there, and that's what, so this null means, right? You omit the attribute in a record. This is one way to think about it, and this is how I'm presenting it. You just need to be aware that some other people would consider that null is just a value like any other that you can add to the domain. So you could have a domain that also has null as a value, and then you're fine, right? But I think that typically the way that people logically think about this is that you're just missing the value. So this is what actually would happen there. Okay. So this is an example of welcome to the real world, right? So this is actual data. It's actual companies who have actual day-to-day businesses, and so in real life we have to do this. Okay. But I have good news, is that you're in control. You can decide when you define your schema if it's okay or not to allow null values. So if I take this example of a schema, if I really, really want my relational integrity because I don't want the cat to be upset, then all I need to do is add not null for every one of my values. So here I did it for first name. You could do it everywhere. And then you're fine. Then if you put not null everywhere, then you know relational integrity is guaranteed, right? So you can also put null, but that's the default anyway. If you put null, it means that it's allowed, right? So that you don't need to do, but you can. All right, so you could specify everywhere. And here you would just allow for middle initial and last name, you would allow it to be null, but otherwise not. So again, if you really want relational integrity, just put not null everywhere. It's anywhere recommended, right? If you create a database, you should try to constrain it as much as possible for the data to be as clean as possible, right? But there might be cases where you have to add null because again, this is the real world, and we don't all fit into math. I'm going to stop here for today. So now you know how to create tables, you know how to specify the attributes, how to add the types. You know that PostgreSQL can break relational integrity. You know how to stop it if you want to add not null everywhere. And maybe I can just quickly, before I let you go, show you like this, what it looks like if you, maybe some of you already saw it. But this is basically the idea, right? You have your notebook and what I showed you, the create table and so on. You can put it in there, you can play with it, right? So don't hesitate to try things out. You can put your own types and your own values and experiment and so on. And so you see that here you have if I click and I can execute, it's real. And now I can answer your question because you asked about true and false. So let me try to put false like this. You see in lowercase, and it works. You see, so it actually works. What if I just even do this just to see? It also works. So you see, it's actually replacing it with an actual false, right? So the answer to the question about the literals is that you can also use lowercase, uppercase. It doesn't matter for true, false. All right. So I will let you go. Thank you very much, everybody, for attending the class. Enjoy the exercise session, and see you next week at 10 a.m. Thank you very much.